Okay, so let's go on and look at some of the different types of plate movements that are associated with plate tectonics. So here are the basic plates. Again, we in Oregon live on the west coast of the United States, and the Juan de Fuca plate is the active plate off our coastline. We live in this what's considered the Ring of Fire. So make sure you understand how the rock in the mantle moves, how it sets up convection currents. As the rock gets hot, it gets buoyant. It rises up to the top of the surface of the earth. Some places it breaks through, creating ridges and volcanic activity there. Sometimes it just, as it moves, it drags that section of plate with it, and then causes interactions. And that's what we're going to look at, some of these different interactions. So we're going to look at three different types of boundaries. One is a convergent boundaries, when plates converge. Second is a divergent boundary, when plates move apart. And the third is a transform boundary, when plates move side by side. And each one of these movements creates different types of landforms. So convergent boundaries, there's two convergent boundary scenarios. One is called a subduction zone, and this is where an ocean crust, which is typically much more dense, it's usually a basaltic, or all ocean floor is basalt. When that plate is moving towards a continental plate, the continental plate is often granite, which is much less dense and more buoyant, and as these two converge, the ocean crust dips down underneath the continental crust, and you get a couple landforms right along this edge. You get a trench, which is usually a very deep seafloor or very deep event, mid-oceanic trenches, or and then, sorry about that. On the other side, you get a mountain range, so the coastal range is a result of subduction from just scraping and buckling of this contact area. And you also can get a volcanic ridge inland, and as this basaltic layer begins to dive down into the mantle, it reheats and becomes more buoyant and will move up to the surface in the form of a volcanic arc or ridge. The other scenario for convergent boundaries are when two continental boundaries collide, and so you've got two layers of granitic continental crust, and while the lithosphere may still sink down below one area or another, these things are crazy. What you get is a buckling and a folding of the continental crust, and this is what the process that's created the Himalayan mountains. The second type of plate movement is divergent plates, and this is where magma is upwelling, creating convection currents on either side of this crack or this upwelling. A great example of this is the mid-oceanic ridge. So you get rifts, you get stretching and thinning of the crust, and volcanic activity along that area. The third type is a transform plate, and this is classic of the San Andreas Fault. And this is where you get two plates moving opposite side by side. So you're not getting as much vertical displacement, but you're getting horizontal displacement or movement. So make sure you look at the example in the book that's showing the direction the plates are moving. You can see the Juan de Fuca plate right here. It's a subduction plate, but it's on this larger Pacific plate. And over on the other side of the Pacific plate, these arrows indicate subduction zones. So here's Indonesia, the subduction zone, the location of the large tsunami event, Christmas a few years ago. All along the west coast of South America, there's a subduction zone. So just really kind of get a sense of where these plates are active and where they're moving apart. The other thing the book talks about is this idea of the relationship between earthquakes and volcanoes and plate activity. The web-based GIS that you're going to use will look at these principles and the landforms that are associated. But make sure you understand the connection between earthquakes, volcanoes, and the different types of plate movement. So, and then in the chapter he talks some about the rock cycle, and it really is a cycle because rocks, this is a great diagram looking at the two different processes, the endogenic and the exogenic processes, where the endogenic processes are things that are happening under the surface of the earth, and the exogenic processes are happening on the earth's surface. And most of the material that we're talking about, volcanic activity, earthquake activity, rock formation, the majority of that is happening as endogenic processes, except for weathering and the creation of sedimentary rocks. So the rock cycle, here's another diagram from the text, really talks about how one kind of rock, say igneous rock, can be created on the surface, can be worn down and moved by water and wind, could be re-cemented as sedimentary rock, and then maybe with pressure and heat created into metamorphic rock, and then perhaps moved back down and remelted again. So it really, this idea of a cycle is pretty correct. Volcanic rock, igneous rock, can either be intrusive or extrusive. Intrusive rock is volcanic magma that has cooled under the surface of the earth, and then through uplift and erosion is then exposed to the elements. Extrusive rock is rock that has flowed as lava, magma on the surface is considered lava, has flowed as lava and then cooled and then exposed to weathering. So the diagram talks about the different rock types. Look at this in your book. Be able to define several of these terms: magma, batholith, laccolith, a sill. I think he has good explanations of that in the book. Yosemite, this is a great example of an intrusive granite batholith. This was a huge reservoir of granite that cooled under the surface and then was uplifted. The overlying layers of rock and soil were removed and eroded, and we're left with this great, huge rock surface. Basalt towers, and so let me go back to this. Granite, basalt, and obsidian are all the same chemical makeup, but of igneous rock, all types of igneous rock. Sedimentary rock is the second type of rock, and sedimentary rock is created from other kinds of rocks. So as granite erodes, silica and other minerals may be released. Those minerals are blown by wind or moved by rain or stream water and collected, and then through a process of lithification are cemented or solidified into another form or to a rock. So they can be solidified by iron, they can be solidified by silica. So that's one type of sedimentary rock. So here's some examples of sandstone along the Oregon coast. And again, these layers were originally put down horizontally, and through subduction, the coast range has been uplifted and these layers have been tilted. It's more sedimentary rock. Again, originally would have been horizontal layers of rock. There's also conglomerates, which look a little bit like concrete, so it's large chunks of rock and gravel that have been cemented together. All of those are sedimentary. A special kind of sedimentary rock is called an organic biological, and this is coal. And this Coal is created from organic material that's been hardened over time. The most common sedimentary rock is limestone, and limestone is made from bone and shell and laid down in a water environment, often oceanic environment, and then these layers are uplifted. So Florida is predominantly all limestone. Many places in England are limestone. The third type of rock you need to know are metamorphic rocks. And metamorphic rocks can either be originally sedimentary rock or volcanic rock, and these rocks have been metamorphosized or changed as a result of pressure. So you can imagine the great forces from tectonic compression that would maybe squeeze and press and change a rock, and it actually changes the crystal structure, or from heat, so coming in contact with magma could change a rock's chemical makeup. And so there are several examples of rocks and what their counterpart is once the rock has been metamorphosized. For instance, limestone is changed into marble. Shales can be changed into slate. So make sure you look at those aspects of the chapter as well.